This will be our final discussion about the evaluation test one paper, right? So I'll show you our structured essay second question. Okay, first part is about periodic properties and the second part is about hydrogen emission spectrum, right? Now look at the information they have given about our question, right? It says covalent radii and first ionization energies of several non-transition elements of the third period are given in the following table. So if you go to the periodic table, in the periodic table actually you have the periods are the horizontal ones now. So first period you have only hydrogen and helium. In the second period you have lithium to neon, right? In the third period, you have sodium to argon, right? So you have 8 elements in that third period, right? You have 8 elements in the third period. I'll write them in the board. Those elements are belonging to the S block and P block. That's what I'm going to show you here. So these 2 elements belong to the S block and these 6 elements are belonging to the P block. Okay, so non-transition. I hope that part is clear. Then let's go to the question again. And then they says the given symbols are not standard chemical symbols of the elements and those are not in order. So they have used several English letters from A to G, right? So they says they are not in order. Okay, and the given elements are consecutive elements. So that point is also important. So if you check the list, you have only 7 elements, right? 7 elements, but here you have 8 elements now. But then they says the elements are consecutive. What's the meaning of that consecutive word? That means they are in order. So if you start from here, either these elements can be sodium to chlorine. Okay, that's one option. Option 1. Or in the other option is these elements can be magnesium to argon. This is your option 2. So because these elements are consecutive, okay, so these 7 elements should be in adjacent to each other. Understand? So you need to check which possibility is true. Is it sodium to chlorine or is it magnesium to argon? You have to select which one is correct. Now they have given you covalent radius, ionic covalent radius and first ionization energies. So what we know about the covalent radius? Okay, so covalent radius you can write here. Covalent radius decreases across the period. So which element is having the largest radius? Largest radius should be there with the element. You can see 157 is the largest value. So F is the first element. Because it is 157. Okay, then the other number is 136. 136, the relevant element is D. Okay, and then you have 125 B. 125. Then you have 117 C. Then you have 110 from G. And then you have 104 E. 104. Finally, you have 99 from A. So you have 7 elements in this order. Understand, Lamai? So first of all, understand about the radius. So radius decreases across the period, right? So F should be the one with the largest size. Should be larger. And related to that, these should be smaller. Across the period, radius decreases. We all know that. So arrange the given values in the descending order, right? Descending order. Then in that same order, you have the elements across the period. But we have a problem, right? We are not sure whether it is option 1 or option 2. Option 1 means we don't know whether it is from sodium to chlorine or is it from magnesium to argon. Understand? Right? So, but we know the order, right? So to check, get the correct option from these two possibilities, we need to check the next given data, right? So they have given us about the first ionization energy also, right? So now let's remind what is happening to the first ionization energy across the period. Across the period, first ionization energy increases. Okay, increases, but it is increasing in zigzag order. It's not increasing gradually. Remember how the first ionization energy increases, right? It is increasing in this zigzag order. This is the order they increases. Okay, so you have 3 elements, another 3 elements. This is how the 8 elements are arranged across the period. So IE1, you can say, increases across the period. Across the period. Across the period, first ionization energy increases, but it is not increasing gradually. Remember that one very well, okay? So it's not increasing gradually. Okay, so now we have two options now. Let's say this is option 1, then it is sodium. This we'll draw the possibility here. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, and chlorine. This is one option. And the other option is starting from magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. These are the possibilities now. Now let's write down their first ionization energies, relevant first ionization energy. So if it is the option 1, how should be the first ionization energy? The variation is happening. Sodium is having the lowest. Okay, then aluminium, then magnesium, then silicon, like that. The highest value will be there for the chlorine. Understand? Highest value will be there for the chlorine. But if it is the second option, lowest value will be there for the aluminium. Okay, so what's supposed to be now aluminium in this first option? Aluminium is our, we'll take aluminium, is very easy to understand then. Aluminium is the third element. Okay, in other words, let's say like this. Okay, let's say like this. So in this order, first element is the one with the lowest first ionization energy. If it is the option 2, your second element is the lowest ionization energy. Now that means if this second order is true, B should, what is the second element? It is D, no? D should have the lowest first ionization energy. Okay, but if this first order is true, first option is true, your fluorine should have the lowest, not fluorine, F element, F should have the lowest first ionization energy. Understand? So now let's check the given values for the ionization energies. Only check these, right? Then you can figure out this one. So the element is, element F value 495.8. 495.8. So is it the lowest value? You can quickly check through the values. Yes, 495.8 is the lowest value. Yes, that means this first option is correct. Now let's prove that second option is wrong also, right? So element D is having 737.7. So, but it is not the lowest value, right? It is not the lowest value. So second option is not going to work. So that is how you identify exactly what are these A, B, C, D. Understand? So most students try this question and they figure out the radius thing, but because with the radius thing you get two options, no? So some of them could not identify the option 1 and option 2. Okay, so now I am telling you that point. How do we identify option 1 or option 2? Just check the first ionization energy. According to the option 1, right? According to the option 1, our F element, or the first element should have the lowest value, right? According to the option 2, our second element, or here it is D, or in other words aluminum, should have the lowest value, right? So when you check the values, okay, when you check the values, F is having the lowest value, not D. Understand? F is having the lowest value. That means this order, this proper order is what? First option. That is how you identify whether it is option 1 or option 2. Right? Is that clear, Lamai? Are there any doubts? This is the kind of the trickiest question in the structured essay paper. This is your answer script. Yes, these are the elements. So then A is supposed to be what? A should be chlorine. So I'll show you how to write the answers also. Then now this is the order. No? Then F should be sodium. D should be magnesium. This one is aluminum. Then you have silicon, phosphorus, sulfur, chlorine. These are the elements. I hope it is clear, right? So according to the radius, identify the element order and then confirm the two options, which one is correct by checking the ionization energy. That's the summary of this question. Okay, now after identifying those, you have to try the rest. What is the element with the highest electronegativity? So from this list, highest electronegative element is chlorine. Because our correct option is sodium to chlorine. So electronegativity increases across the period. Okay, we are ignoring the noble gases. So anyway, this noble gas is not coming for our option. So chlorine is the most electronegative element from the list. And then it is asking which element is the least electronegativity. Lowest electronegativity is there with the sodium element, the first one. And then it is asking about electron gain energy. Okay, can you write that one? In front of third question, right? Electron gain energy. Electron gain energy. So it is asking most likely to gain an electron. Most likely to gain an electron. So which one is most likely to gain an electron? Highest exothermic value. Okay, electron gain energy will be negative for those who like to gain electrons. No? Okay, electron gain energy is negative for those who like to gain electrons. So it is asking which one is most likely to gain electron. So you know, in a given period, always halogen is the one with the highest negative value for the electron gain. So you can write down that point in front of the third one. I'll put it in the board also. You can write this in a given period. In a given period, halogen means fluorine, bromine, iodine, those things. Okay, halogens are the highest exothermic first electron gain energy. So that means it releases energy. Understand? So chlorine is the one that releases or most likely to gain the electron. Most likely to gain the electron. Then check the fourth one. What is the element that is least likely to gain an electron? So you can say least likely means electron gain energy is very low. Right? Low means they don't release energy. Okay. So from that list, from sodium to chlorine, you have one element, magnesium. Magnesium electron gain energy is positive. You can write down that one. Why we select magnesium as the answer? Because magnesium electron gain energy, first electron gain energy is positive. It doesn't like to gain the new electron because it's already having the stable configuration, stable NS2 configuration. Sub energy level is completed. So it is stable for the magnesium. So magnesium doesn't like to gain another electron and disturb that stability. That is the reason. Okay, so magnesium is the element that least likely to gain the electron from this list. Okay, so you can rephrase this electron gain energy using electron affinity also, right? So from this list, highest electron affinity is there for chlorine. Least electron affinity is there for magnesium. Okay, so study that affinity and gain energy part. I kind of reminded you the same thing last week also. I asked you to go through that part. So if you need the theory recording of that topic, you can ask me and get the recording. You can study that part. Study that part. So electron gain energy is a very good topic that you see in first unit. Okay, first unit. Because the thing is, it is an energy. So you have exothermic, endothermic thing, and then you have the that electron affinity problem also, right? So electron gain energy, opposite sign comes for the affinity. Like that, you need to know more facts about affinity and gain energy. So study that topic again. So if you already have a good knowledge about that topic, very good. Okay, so keep the practicing and don't let that part forget. Okay, it's a very good point. Right, so anyway, first 4 questions are done. Now in the 5th one, they are asking melting point variation. Melting point variation. So FDB. So first of all, let's identify what are these elements. F is sodium, D is magnesium, and B is aluminum. So the 3 metals, right? So that is why we need to identify the elements correctly, right? So if you don't identify it properly, then you can't write an answer for this one. So here we have 3 metals, aluminium, sodium, and magnesium. You need to talk about their metallic lattice stability or their strength of their metallic bond. Simply say, you have to talk about their strength of metallic bonds. So now, first of all, you need to tell what is the correct order of increasing melting point. Okay, so I'll explain a little bit about this one in the board. Then after that, we will look at the answer. Melting point variation of sodium, magnesium, and aluminum. First thing you can start, these are metals. These are metals. So if their metallic bond is strong, if their metallic bond is strong, we can say melting point, we can say Tm, right? Tm will be high, melting point will be high. That is the logic, no? Right? You need to then explain about the metallic bond. So metallic bond stability depends on simply 3 things. First thing is free electrons, number of free electrons. Then the next point is charge of the metal ion. Metal ion always is a cation, so the charge of that one. And then the size of the metal ion. Okay, now let's say like this. You have 2 metals. First metal having very large metal ions, and free electrons are also low. For example, we can say this is sodium. Sodium is having +1 ions and it is losing only 1 electron for the free electron club. And then take the other element. Let's say it is aluminium or something. So it is having +3 charge and there are more free electrons. Understand? So between the electron and the metal ion, this metallic bond occurs. Okay. So now if you take this unit volume, let's say the same volume, V volume is taken. Right? If you take this V volume, you have very fewer number of metallic bonds, no? In a unit volume. But if you take aluminium, the other example, you will have very high number of metallic bonds. Okay. So more metallic bonds in unit volume. So that means this one is stronger. So then what should cause this stability? What is causing this stability? If your number of electrons are higher, number of free electrons are higher, then if the charge of the metal ion is higher and the size of the metal ion is lower, you will have more metallic bonds in unit volume, which cause it to be stable. Now if you take sodium, magnesium, aluminium, this example, sodium, magnesium, aluminium, this example, okay, sodium is having only one free electron, magnesium 2, aluminium 3, and their charge is also +1, +2, and +3. If you can consider the size is larger for the sodium plus, and aluminium 3 plus size is very low, small size. So all the factors are favoring a stable metallic bond for the aluminium. Understand? So then you have to say the increasing order of the melting point. The melting point variation, increasing or decreasing order is allowed to write. So you can write sodium, magnesium, and aluminium. Or you can write aluminium, magnesium, and sodium. This way, any order is fine because they are just asking you for the variation. They are not asking ascending order or descending order. You just can write like this. Okay, so this is the explanation about metallic bond. So try to understand that one. Try to understand that one. Now this is the way you have to write it in the paper, the marking scheme. So simply you have to tell aluminium is better than sodium and magnesium. Okay, so how they are getting better? You have to say number of free electrons and charge, those are higher, and the size is low. Look at the points given. Okay, first you tell the order, correct order. Then you have to tell metal cation charge increases in the order of this one. I actually allowed you to write only one option, okay, because with the given space. You can write either about the charge, either about the electrons, number of electrons, or the size, can tell about anything. And then finally you have to relate that metallic bond is stronger in aluminium. Right? You can see metallic bond strength increases in this order. Now go to the question number 6. They are asking you to draw two graphs. Okay, so first graph is about the second ionization energy. Second ionization energy. So once you know the elements correctly, you can get the second ionization energy. Now from sodium to chlorine, right? Sodium to chlorine, second ionization energy. Sodium is the one with the highest second ionization energy. Why? Why? So let's write down in our answer why sodium is having the highest value. So if you take sodium electronic configuration, sodium plus an electron is given. This is your IE1. And then in IE2, you remove an electron from sodium plus to make it sodium 2 plus. So now sodium plus is having stable neon configuration, 2s2, 2p6, stable configuration is there. So removing electron is very difficult. IE2 will be very, very high because it is having noble gas configuration. So you have to show that one in the graph. So simply, how did we learn this one in the theory class? How do we get the second ionization energy? So you draw the first ionization energy, then you come one backward. That is how we learned to draw a second ionization energy. You can see it nicely. So sodium is there now in the neon's place. See, one came backward. So actually it is asking above elements. So some students have drawn this one for sodium, magnesium, and aluminium only. Because the earlier question number 5 was based on sodium, magnesium, aluminium. So that is also correct, okay? Because it's a problem with the question. Or you can generally draw the variation of all 7 elements. Okay, so where you have a stable configuration, ionization energy will be higher. That is about sodium, no? What we said earlier. You can write about aluminium and sulfur also. Aluminium plus when we do the second ionization, we are removing electron from aluminium plus. No, aluminium plus is having magnesium stable configuration. Then sulfur plus is having phosphorus stable configuration. That's why their ionization energies are higher than the adjacent ones. They will name the axes also. Marks are given for that too. Right, then you have another graph to draw. There as the seventh question. It is asking you to sketch the successive ionization energies of the element D. Element D. Element D is magnesium. Identified that one, see. Element D is magnesium. So magnesium successive ionization energies. Successive ionization energies means you are removing electrons one by one. Okay, so I'll explain how that graph came. If you take the magnesium electronic configuration, it is 1s2, 2s2, 2p6 and 3s2. 3s2. And this is there in the first energy level. These 8 elements are there in the second energy level. And the last 2 electrons are there in the third energy level. So these electrons most distance away from nucleus. So therefore felt a minimum attraction. Understand? So it's something like this. If you draw this one according to Bohr model, it is more easier to understand. Right? So these last 2 electrons are located away from the nucleus. See, much distance is there. So you know that when the distance is higher, attraction is lower because they all happening according to the Coulomb's law. Coulomb's law says force is inversely proportional to the square of the distance. Okay, so once the distance is higher, it is feeling very low attraction. So that means easier to be removed. It is very easy to remove these 2 electrons. Understand? So when you supply energy to this atom, which electrons will be easily removed? The outermost electrons, magnesium's outermost electrons, 3s2. So those electrons will be easily removed. And then to remove other 8 electrons, you have to supply kind of a higher energy. Okay, and the innermost electrons are very difficult to remove. So like that. So you can expect small deviations among these 8 elements also, 8 electrons also. But we are not that much expecting you to draw that in a graph because it's kind of difficult to show that small deviations. But there will be a clear gap between energy levels. Okay, so this is the one you have to draw. So then you can write down the explanation in the board. It's explained how this graph came. So in your paper, basically everything that can be asked from these lessons are asked, Lamai, okay? Where whenever you need to revise the topic, okay, you can go through our paper, write a review, do the same paper again, okay, do it. Now let's go to the part B. Now 61 marks are allocated for the part A, okay? So now look at the part B. It is from the emission spectrum thing. And the table giving you data regarding the energies of main quantum numbers. What is meant by main quantum number? You can write there energy level. So this table is giving you the energies of energy levels. So first question is asking frequency of the red spectral line of the Balmer series. Okay, frequency of the red spectral line of the Balmer series. Frequency of red line. Red line, anyway, the visible part is Balmer, no? So you don't need to say Balmer. But anyway, it has said Balmer series. That's the question they're asking. They have given you the energies. So now, these energies, you can see there are negative values. Energies are given in negative something kilojoules. Okay. And you can see the first energy level energy is negative 2.18. and into 10 to the power minus 21. Okay, that means it's a higher negative value. Then look at the second energy level energy. 5.45 into minus 22. It is a lower negative value than the first energy level. That means the energy of the second energy level is higher than the first energy level. That is what we are expecting. No? Okay, so this given data is is matching that theory part we know. So what we know is if this is first energy level, if this one is second energy level should have a higher energy than the first energy level. That is represented here. So no problem. So only thing they have given you negative, so given you the energies, actual energies in using negative values. So minus 2.18 into 10 to the power minus 21, or you can say this one as 21.8 into minus 22. This is more better. Okay, so this one is minus 5.45 into 10 to the power minus 22. It negative value decreases. You can see. And minus 2.14 into 10 to the power minus 22. This one is minus 1.36 into 10 to the power minus 22. So upward, what is happening? Negative value decreases. That means energy increases. That should happen. So it is happening. So after decreasing, what will be the the lowest negative value? That means what will be there at the end? The infinite energy level. Let's say here, this one is our energy of the infinite energy level. It is going to be 0 kilojoule. Remember that one. 0 is the energy of infinite energy level. Outermost energy level. Okay, so now you need to understand this simple thing about energy level energy. So I hope it is clear to you all. Right, now about the transitions. Now in emission spectrum, you have a separate video about that one. But whenever you forget this emission spectrum thing, right? If you need to revise the theory, go through that recording. Okay, it's available. Right. So if you need that, please ask again. So let's say this. Simply, if I say electrons are exciting from low energy levels and moving to the upper energy levels by absorbing energy. Right. So that energy can be released again, and those electrons will come back to the low energy levels. That is what happening during this emission spectrum. Okay, so electrons that jump to upper energy levels can come back to low energy levels in several ways. Okay, so those electrons can come to, let's say there is electron in the fourth energy level. That electron can come to third energy level, then second energy level. Like that, it can descend in several ways. Okay, you can draw 3 lines. So those are jumping to the first energy level has the highest energy. So highest energy, so they belong to the UV region. And the series name is Lyman series. And this one is having a kind of moderate energy. And this is belong to the visible region. And name of the series is Balmer. These lines are visible. Only 4 lines in Balmer series is visible. So first line is red color, second line is green color, and there are other lines RGBV. Red, green, blue, violet, energy increases. Okay, so this one is from n equal 3 to n equal 2. This is the transition. So they are asking the frequency of this transition. And this single one I have drawn here is belong to the Paschen series. Okay, so now you can identify the energy of the relevant transition is 3 to 2. Okay, so then you can get the energy difference between second and third energy levels. Okay, so this is relevant to delta E is E3 minus E2. So energy of the third energy level is minus 2.14 into 10 to the power minus 22. Then you have to subtract minus 5.45 into 10 to the power minus 22. Considerable amount of students had done this one well. Okay, it's really good. So understand this one. Now you can get the difference and it will be a positive value because minus minus is positive plus. No? So you'll get the difference. Okay, so that difference is there for one electron. One electron, because you can see in the question, I think it is given that energy difference is there for one electron. Yes, that is for the energy level. It's there for one electron. So even though they have given Avogadro constant, you don't have to use it. It is given in kilojoules, no, not kilojoules per mole. Ne? It's not the unit kilojoule per mole. It is given in kilojoule unit. So you don't have to use the Avogadro constant. So what is the value is coming? 3.31 into 10 to the power minus 22 joules. Okay, this is the energy released when one electron is transferred. So this is released as a photon. Energy of red color photon. You know, in quantum theory of waves, it is telling energy is contrast. Energy is contrast. So energy packets are moving. Energy packets are moving. So there is a red color packet. So red color packet energy is, red color photon energy is this value. So now energy of one photon is expressed by Planck's equation equal h nu. So the Planck constant is given there. Energy we just found. Okay, and they're asking the frequency. Just use this Planck equation and find it. Okay, so I hope that is clear to you all now. This is how we do the second part. We find the energy difference, then apply that equation. You can do the steps together. That also given marks. That means you can derive an equation and do. Anyway, this is more simpler in this way. So 5 marks are offered for you for identifying the transition is from 3 to 2. Okay, so like that marks are allocated for several steps. So is that clear, Lamai? That part. Finding frequency of red color line. Because you identify what is red color and then get the energies. What is the transition for red color? 3 to 2. And then get the energies of those two transitions, those two energy levels, and get the difference. Then you get the energy released during that transition as a photon. And then find the frequency of that photon. That's the way. I hope it is clear. Right, then go to the next part. There's a part 2 of this question. It is asking to calculate the first ionization energy of hydrogen. First ionization energy. Now it is asking you to consider the energy of the infinite energy level as 0. But we can understand that happens. Anyway, during first ionization, hydrogen is having only one electron. So during ionization, what happens, Lamai? That single electron is removed. So removing, in the sense it says, removing means kind of being free from the attraction of the nucleus. Okay, so if you go to the infinite energy level is the one that feels the minimum attraction. Okay, infinite energy level is the one that feels the minimum attraction. Okay, so during ionization, what is simply happening? Electron is moving from first energy level to infinite energy level. Okay, so then this is the energy difference you need to check. That's why I wrote it as a sentence, or you can just simply express it as an equation. So energy difference is simply equal to infinite energy level energy minus first energy level energy. Infinite energy level is 0. So first energy level value comes as the energy difference. Then they're asking it for kilojoules per mole. Now you found in kilojoules for one electron. And then multiply that by Avogadro constant to get it for 1 mole of electrons. Okay, so That is how the second structured essay is asked. First part is about periodic properties, and the second part is about emission spectrum. So there were many other emission spectrum questions we did in our earlier paper classes. Okay, before evaluation test, I think we have done around 18, 19 practice papers. So go through them again, Laman. Okay, now some of you are having term test in December or January, right? So you have to be prepared for that one. So go through those papers again, because in your first term test, they will ask from unit 1, 2, and 3. There are 2 essays in our paper. Both are from chemical calculation. So I asked you to choose one and do. Okay. And yeah, some of you selected the first one. First one is the most common question you selected. So anyway, we will discuss about that question, how to get the answer and other things. Look at the first question. There are 3 parts in the first essay question. Question number 3, you have 3 parts. Part A is from limiting reactant and those stuff, and part B is for balance an equation, a balanced set of chemical equations, and then part 3 another chemical calculation. Okay, so I'll put the data in the board and I'll explain, and later I'll show you the marking, okay, because anyway the answer is there, but I need you to understand how to do the question. Okay, so it says 14.4 grams of C5H12. So C5H12 is there. It's a hydrocarbon and it is completely combusted. So during complete combustion, what is happening? All the carbon is going to carbon dioxide and all the hydrogen is going to water. Okay, and it is completely combustion is done with 12.044 into 10 to the power 23 molecules, right? And it is done in 127 Celsius in an evacuated rigid container. So it says H2O exists as a gas at 127. Carbon, hydrogen related atomic masses are given. So now this question actually guiding you to do showing you the proper way. Okay, so look at the first one, they're asking you to balance the reaction. So like I said in the question, all the carbon converts to carbon dioxide. So there are 5 carbon atoms. So you will get 5 carbon dioxide. And there are 12 hydrogen atoms. You will get how many water molecules? You will get 6 water molecules. Okay, so to prepare 6 water molecules and 5 carbon dioxide, you need how many oxygen atoms? Here you need 6, and here you need 5 into 2, 10. 16 oxygen atoms are needed. So that means 8 O2, 8 oxygen molecules. Okay, so C5H12, 8 O2, 5 CO2, and 6 H2O. Is that clear to all of you? Right, this is the balancing. So that's the first question they're asking. Balance this equation. Later I will show you how the marks are given. Okay. So then it is asking what is the number of moles of C5H12. So mass is given 14.4 grams. You have to use the simple M over capital M formula. Okay, simple M over capital M formula. So for that, let's do it somewhere here. Okay. For that, we need the molar mass. So you have to show how you are finding the molar mass. Okay. Marks will be given for that. So 12 into 5 plus 1 into 12. 12 is the relative atomic mass of carbon. So 72 grams per mole. Then to find the moles of C5H12, you have to divide this mass 14.4 grams by 72 grams per mole. So it's divisible. 0.2 moles are there. And in the third question, they are asking for us to find the oxygen moles. So for that we are using particles over Avogadro constant form. So 12.044 into 10 to the power 23 and divide this one by Avogadro number 6.022 into 10 to the power 23 per mole. It is exactly 2.0 moles. 2 moles. Okay, so that's the third part. So you have to step by step do this process. First balance the equation and then find the number of moles. Is that clear, Lama? Balance the equation and then find the number of moles. And then look at the fourth part. It is asking you to find the limiting reactant using a suitable method. Right? So what is the method we are using to find the limiting reactant? That method is called ARR. Added, reacted and remaining moles. So they all are from moles, okay? Added, reacted and remaining moles. So we have added C5H12 0.2 moles. And from this you have added 2.0 moles. So which one is the limiting reactant? Which one is the limiting reactant? Okay, so let's see how to identify that. So now, always you have to work with the ratio. Now C5H12 to O2 ratio is what? 1:8 now. So that means 1 mole of C2H5 is reacting with 8 moles of O2. Now let's say you got 0.2 moles of this now. So to react with that, you need 8 times like that. That means 1.6 moles of O2. So do we have 1.6 moles? Yes, we have more than that. So therefore this is possible to happen. Understand? Because 1.6 moles are there. And then check the other way. You have 2.0 moles of O2. But do we have, we need to divide that one by 8 now. So if you divide this one by 8, you will get 4, 2.5 and yes, 2.5. 0.25, sorry, 0.25. Do we have 0.25 moles? No. Therefore, this will not happen. So like that, understand the correct ratio. Correct ratio. So according to this one, total 0.2 moles of C5H12 is reacting. With that, 1.6 moles of O2 is reacting. And if you work out the stoichiometry for this one, 5 is formed from this, no? That means 1.0 of carbon dioxide and 1.2 moles of H2O gas is formed because this is water is existing in the gaseous state. Right? So remaining here C5H12 is completely consumed. So this is the limiting reactant. And here 0.4 moles are remaining, 1.0, 1.2 moles are there. Okay, 0.4 moles are remaining. 0.4 moles are remaining from water. So your limiting reactant is what? Your limiting reactant is C5H12. So the suitable method is this one. You need to show that one using the ARR method. Is that clear, love? You need to show that one using ARR method. And then they are asking what is the mass of CO2 produced. Okay, so simply what you need to do, get the molar mass of CO2 and multiply that from the moles of CO2. So in the question we just completed, we saw carbon dioxide, 1 mole is formed. So you will get 44 grams of CO2, no? 44 is the molar mass of CO2. And then finally, it is asking you to calculate the mole fraction of the excess reactant. So this one, most of you got wrong. Okay, let me explain that part. So what is the excess reactant, first of all? Excess reactant is O2. Excess reactant. Excess reactant. So they are asking the mole fraction of the excess reactant. Mole fraction of the excess reactant. So you have 0.4 moles of excess reactant. So how many total moles were there? When you count the total moles, you need to add all these number of moles. These are the total remaining moles. So you have to add 0.4, 1.0 and 1.2. So 2.2, 2.6. So 0.4 over 2.6. Or you can just say 4 over 26, 2 over 30. 2 over 30. So I hope you remember how to get the mole fraction. Mole fraction of O2 is equal to moles of O2 over total moles. This is what we did here. Okay, now, so that is about the first part of the question. First part of the question. So let me show you the marking scheme of that thing. Here, you can see. For balancing, I offered you 8 marks. Physical states are not needed. And then you have to find the molar mass of C5H12. Then for the division, 1 mark. For the answer, 4 marks. So study the marking scheme, right? You have to write like this now. This is a model question. In A-level exam also, you need to meet the same standard. Then look at this moles of O2 dividing. Then applying ARR method. Or you can write it down also. So there's an alternative answer as a sentence. See, to completely react with 0.2 moles of C5H12 from O2 gas, 1.6 moles are needed according to 1.128 ratio. Although O2 is added more than that excess, therefore C5H12 is limited. That sentence also given marks. I saw only few, very few students has write that sentence thing also. Majority of you tried with the ARR method I taught. Anyway, both are correct only. And then CO2 moles, this is how you find it, molar mass and number of mass of the CO2. And then finally, moles of the excess reactant. First of all, identify the excess reactant. And then get the mole fraction, after finding the total moles. So like that, marks are offered, 40 marks are offered for this. Then you have 5 equations to balance. And these are the answers of those 5 equations. I'll simply say what to do. Now these points I know you all can understand. So I'm not going to waste time on that. So here we are using inspection method. By the time we write the exam, we don't know the redox method now. Okay, so that's why I gave the question like this. You need to balance it using the inspection method. So simply you check the atoms in 2 sides and add numbers. Now first one, N2O5 goes to NO2 and O2. Okay, most of you did those things well. Some of you may face a trouble at the second one because the values are big. Okay, 4, 5, 4, 6. And lithium nitride with water. There's a combustion reaction. You need to remove the fraction by multiplying the whole thing by 2. And then the final one, fifth one, is an acid-base reaction. In acid-base reaction, what is forming? A salt and water. Salt and water is formed. So now I'll explain that salt thing because I remember some of the students got that part wrong. So the acid is H3PO4, base is potassium hydroxide, KOH. Now here what are the ions? 3 H pluses are there. Okay, because acids are releasing H plus. So if you are having H3, then there are 3 H pluses. So relative to that, PO4 3 minus should be the charge. Because finally when you put this 3H here, charge should be cancelled. And here you are having K plus and OH minus. Bases are releasing OH minuses. So then you need to balance this now. Check the valencies, 3 and 1. Then cross that one. So K3, when you are writing the formula, you have to write like this. K3 PO4. So that means you need to multiply this one by 3. 3 should be there in front of KOH. So then how many water molecules are formed? 3H plus and 3 water is joined to form 3H plus and 3 OH minus are joined to form 3 water molecules, 3H2O. This is how you balance that. Okay, when you do the questions also, take this ratio, 1:3 ratio, and do the question. If 0.6 moles reacted with this one, 0.2 moles will react with the other one. Like that, you can use the ratio also. In our after learning redox equations, you did the same kind of questions. Okay, same thing. Then let's look at the part C. Part C is another calculation for you to do. Okay, so look at that one. Let's do that also in the board. The procedure was carried out to find the percentage of impurities in solid sodium hydroxide sample. You have a sodium hydroxide sample and there are impurities included to that. We need the impurity percentage. Impurity percentage, mass percentage. Impurity mass percentage is asking. Then 10 grams of this sample was dissolved in 100 cubic centimeters of water. 100 cubic centimeters of water. Then 10 cubic centimeters was taken and diluted with water to 250. So you separate 10 cubic centimeters and then add water until it reached 250 cubic centimeters. Diluted solution. From that 25 is taken. From that 25 cubic centimeters are taken. And that is titrated with H2SO4. H2SO4 concentration is 0.1. From it, 10 cubic centimeters are consumed. That's why it is telling endpoint. Okay, now let's find out the impurity percentage. So this is the same question you had in your theory tube. Right, we did that one in the class. So I anyway gave you to do that again. Okay, so during you can see here, there you have separation. Here also you have separation. Because you are separating 25. And this one is dilution. So during dilution, number of moles are not changing. But in separation, number of moles are changing. How do we do this question? First of all, I'll show you the sketching. First of all, find the moles of H2SO4 by multiplying concentration and volume. Concentration and volume are given here. Then write the equation, the balanced chemical equation between sodium hydroxide and sulfuric acid. Na2SO4 and 2 water are formed. So they are reacting in 1:2 ratio. So then find out number of moles of sodium hydroxide. But remember that sodium hydroxide was there in 25 cubic centimeter. Okay, so you simply multiply this value by 2. And then you can find moles of sodium hydroxide in original 250 centimeter cube. Because there was a separation. So simply divide this one by 25 and multiply by 250. Okay, now let's find the answer for this one quickly. 0.1 mole per decimeter cube into 10 into 10 to the power minus 3 decimeter cube. No? So it's 1 into 10 to the power minus 3. So 1 into 10 to the power minus 3 into 2 sodium hydroxide moles will be 2 into 10 to the power minus 3. So that one divided by 25 and multiplied by 250. So it becomes 2 into 10 to the power minus 2. This is the number of moles on 25 here, 250. But that is also a result of dilution and separation. No? So then we can say moles of sodium hydroxide in 10. That separated 10 cubic centimeter. That is same as this value, no? Because in dilution, number of moles are not changing. So now we can find out sodium hydroxide in 100 cubic centimeters original. Okay, so simply what you do, divide this one by 10 and multiply by 100. So you get 2. Simply 2 into 10 to the power minus 1 or 0.2. This is the number of sodium hydroxide moles present. Then you can find the molar mass of sodium hydroxide. Then find the moles of sodium hydroxide. So to find the moles of sodium hydroxide, simply multiply this value by molar mass, 40. You get 8 grams. So impurity mass is what? Impurities are 10 minus 8, 2 grams. So impurity percentage is 2 grams over 10 into 100, 100%. From the total gram, 2 grams are impurities. So 20% is the answer. Third part of the first essay question. Is that clear to you all now? You have to show the stoichiometry also separately. 25, 250, 10 and 100, you have to find the moles. And then impurity, sodium hydroxide mass, and then impurity mass and mass percentage. So you have offered 30 marks for that one. Then let's look at the fourth question. That means second essay question. There are two questions given. First one is an acid-base titration. But it is a little bit special. Why? Because you have two acids. You have an acid mixture. I'll just remind you by doing the question how to do these sort of problems. First of all, let's put a diagram. H2SO4 of a certain concentration. We don't know the concentration. And after mixing, you get an acidic solution. The acid mixture contains 30 cubic centimeters. Then it says when the solution is titrated with 0.5 barium hydroxide. Now you are titrating that same whole solution with barium hydroxide. Barium hydroxide concentration is 0.5. So it says 13 cubic centimeters of 0.5 barium hydroxide is spent. Right? The first thing they're asking you to write the balanced chemical equations between barium hydroxide and HCl. Barium hydroxide releases 2 OH minuses. So you can write the equation like this. See? It reacts with 2 HCl and it reacts with 1 H2SO4. 2 HCl and 1 H2SO4. Is that clear? Then they ask in the sulfuric concentration. Okay, so let me show you the steps for you to find the sulfuric concentration. First of all, find the moles of barium hydroxide. Find the moles of barium hydroxide by multiplying the concentration and volume. Then find out moles of HCl, concentration and volume. Then get the ratio. HCl reacts with barium hydroxide in a 2:1 ratio. 2:1 ratio. Okay. And then you can find out barium hydroxide. That right steps, okay. Barium hydroxide reacted with HCl. Okay, so let's say this is X, right? And then you can find barium hydroxide reacted with H2SO4 by doing what? Because we know the total value now. So this total barium hydroxide minus X. X is the part reacted with HCl. If you subtracted that from the total, you will get the barium hydroxide moles reacted with sulfuric. Okay, so then you can get their ratio. Their ratio is also 1:1. Then you know the moles of sulfuric. Then you can go to the concentration of sulfuric. See? Remember this one. Okay, so most of you did that well. So anyway, I practice more chemical calculations. And these are the steps. These are the steps. Moles of barium hydroxide reacted. Then moles of HCl reacted. You get the ratio and find the barium hydroxide reacted with HCl. Then take the difference. Then that gives you the barium hydroxide reacted with sulfuric. Then get the barium hydroxide, sulfuric moles. Then finally you can get the concentration. Right, now shall we go and check the part B of that question? Look at that question, Lama. Following procedure was carried out to find the concentration of NaNO3 solution. 25 cubic centimeters of NaNO3 solution was taken into a beaker, and excess aluminium metal powder and excess sodium hydroxide was added. Following reactions occur in the basic media. Now, this is actually a redox reaction. We learn how to balance this one also. And for your exam, we didn't do redox yet in that time. So I gave you the balance equation. You just have to use it. But you can see there, all the NO3 minus available converts to ammonia gas. Okay, all the NO3 minus available converts to ammonia gas. If you have 3 NO3 minus, 3 ammonia is given. Okay, so then liberated ammonia was found by reacting with sulfuric acid. It's not even a reverse titration. Okay, it's just a simple titration. Remember in our previous theory classes these last few weeks, we did essay questions, no? Past paper. When we do past paper essay questions, I repeatedly said reverse titration like that. Okay, so actually ammonia concentration is found by a reverse titration, but for this question, it was not considered. Okay, so it is just titrated with H2SO4 solution. So 40 cubic centimeters of 0.05 H2SO4 was required. And you can start the question by balancing this equation between H2SO4 and ammonia. Then find the moles of H2SO4. Then go to the moles of ammonia. Moles of ammonia will be 2 times like the H2SO4 moles. Okay, so you have been guided also by, you can see the way the question is asked. First it is asking the sulfuric moles. Then ammonia moles liberated. Balance and show. And then nitrate moles also is equal to that value. Then moles of NaNO3 is also equal to the nitrate moles. Then you can find the concentration of nitrate by dividing from that 25 cubic centimeters. Okay, I'll show you how to do that question parts from 1 to 5. 1 to 5. See the answer here. See, first of all, you find the sulfuric moles. Then write the equation and balance. Then you get the ammonia moles from the ratio, 2 times like the sulfuric moles. And then ammonia moles and nitrate moles, you have 1-to-1 ratio. Okay, and then you get the sodium nitrate moles. And after that, sodium nitrate concentration. And finally, they ask about aluminium mass. Now, like I'm showing here, you can find the aluminium to nitrate molar ratio 3:8. So if you have 3 moles of nitrate, you have 8 moles of aluminium. That's what they are telling you. So if you are having, what's the value? 4 moles of 4 into 10 to the power minus 3 of nitrate, then you can divide by own stoichiometry and multiply by the required stoichiometry. Remember that. Divide by the own stoichiometry and multiply by the required stoichiometry. Divide by 3, that's the stoichiometry value of the nitrate, no? And multiply that one by 8, the required value. Then you will get the moles of aluminium. Okay, so but we need the mass of aluminium, so multiply that mole value by molar mass of aluminium, which is 27. You will get this 0.288 gram value. Okay, so that question, actually the challenging part is the balancing the redox reaction. So that was not there in the question. That's why the question is easy. And write the review of this whole paper. This paper contains 35 MCQs, 2 structured essays and 2 essays. So you may have done only 1 essay earlier because I asked you to do 1, but then try the other essay also. Evaluation test discussion has come to an end like this. See you again in next week also with a paper, right? Goodbye. Study well. If you have further doubts about the paper, please ask.